Hi everyone, we are on module 4 and we are about to go through and do the Antibiotic Sensitivity Lab. Now this is the lab that gives students the most trouble. It is the most intense and it is the one that has the most amount of instructions, and it can be really confusing. So I'm going to go through this with you step by step so that hopefully we can avoid all the confusion. So the first thing that you want to get is a Petri dish. Okay, and it has the lid and the bottom. The bottom is the one that has the most amount of space, and the lid is the smaller one. And then you want to get this nutrient agar. All right, so the first mistake that people make is that you have to heat this up in the microwave, and people do it too quickly. You have to be really patient. In the directions, it tells you to place it in the microwave and make sure the cap is off, and then microwave and swirl it every 10 seconds. I would do it every 5. I would also place it in a bowl, so have it in a bowl and microwave it like that, so that way if it does end up flowing out, it flows into the bowl. So you're gonna microwave this until it's just warm, and then you're gonna pour just a little bit into the bottom of the Petri dish to fill it. So I'm going to go ahead and warm this up, and then I'll come back whenever it's warm and show you how to fill up the Petri dish. Okay, so I microwaved my nutrient agar. It took about 30 to 35 seconds, and what you want is now it's a liquid. So whenever you first started it was really like solid, and now it's really hot liquid. Don't do the 35 seconds all at once. Like just do like 10-second increments until you get to about 20 seconds, and then do 5-second increments because it can come out of the bottle really quick. So here is my Petri dish. I'm going to go ahead and pour, and see it comes out as a liquid, and I don't have to, I just want to cover the bottom. And see some of it didn't get fully melted, and you'll know because you'll start seeing a chunk come out, and that's what we want to avoid. We want to have a, ooh, that's really hot. So yeah, I should have used the, ooh, there goes that chunk. So that's what I was kind of hoping to avoid, but it's okay if it comes out. Don't try to rescue it or anything, because you'll end up contaminating the agar. So just let it do that, and then quickly put your lid over it, just kind of put it on there most of the way, because you're letting it dry, and then you can put the cap back on your agar bottle. And we don't want too much condensation. So right now I can see that it's getting a little warm. So I'm just going to let it solidify. It takes about roughly about an hour for it to solidify, just depending on, you know, circumstances of your house and everything. So we're going to let that get solid, and once it's kind of done, the heat coming off of it is kind of done, then you'll want to cover it. Just because the longer it's left out, the more likely it is that it can get contaminated with bacteria, because there's bacteria everywhere. So definitely be careful while you're doing this part. One last thing I forgot to mention, you're gonna need this nutrient agar again, so don't throw it away. Just put it in your refrigerator until you are ready to do the remaining part of the experiment, to keep it fresh. Hi everyone, we are on the next part of your antibiotic sensitivity lab, and I've went ahead and switched to gloves now, because you don't want to contaminate the agar. So our agar has hardened. It is no longer a liquid. And like I said before, if you get a little chunk in there, don't worry about it. It's not going to hurt anything. And you don't want to go in after it because you'll contaminate it. So I'm going to put the lid on And what we're gonna do is, oh, I forgot my permanent marker. We're gonna take a permanent marker and we're gonna flip it over, and we're gonna, on the bottom side, put it into thirds, and we're gonna label one section skin, one section local, and one section yeast. And we write it on the bottom because you want to be able to look through the top. Okay. So after we have it labeled, you're going to get one of these sterile applicators and open it. Being real careful not to touch the tip. And so we're gonna have a beaker full of deionized water, just a little bit, and you're gonna dip it in the water just to moisten it, and then obtain a skin sample, like from your forearm. So here's my arm, and don't like clean your arm or anything before you do this. Like don't wash anything, and you're just gonna kind of rub back and forth and swirl it like that for just probably like 10 or 15 seconds. Take your Petri dish, and then you're gonna streak the skin part, okay? And you're gonna move it, you're gonna start at the edge and you're gonna move it along in a zigzag pattern back and forth, and kind of twirl the tip as you do so. And it's gonna mess up the agar, and that's okay. Okay? And then put the top back over it. Okay? And so that's your skin sample. And then we're gonna dispose of this. Okay? Then take another cotton swab and dip it back into the water, and then rub that cotton swab on a local area, so like a doorknob, your phone, your kitchen counter, whatever you feel like doing. Just make sure it's not a place that you have recently cleaned, because if you do that, then you're probably not going to pick up any bacteria. So I'm going to just dip it, and I am going to rub mine on a doorknob. Actually, I'm going to rub mine on a light switch because that's kind of the closest thing to me. So I'm going to step out of the frame for just a second. Okay, and once you've obtained that sample, you're going to do the exact same thing. You're going to streak it on your agar plate, on your local. Be really gentle, okay, starting at the tip and just kind of rubbing it all over that local area. Okay. Now we need to prepare the yeast. So you're going to have 230 milliliters of warm water in one of your 250 milliliter beakers. You're going to go ahead, and it needs to be warm water so that it'll dissolve the sugar of the yeast. So I'm putting 1 teaspoon of sugar into the beaker, and I'm putting the entire yeast packet into the beaker. Be a little tricky to open sometimes. There we go. Okay, and I am going to use one of my stirring sticks that I don't currently have right now, so I'm just gonna go ahead and improvise and break this into a stirring stick. and just go ahead and stir it. And what's going to happen is that yeast is going to react with that sugar and that warm water, and it's going to start foaming. So like right now I've got some bubbles, almost like whenever you shake a soda can or you first open it, those carbon dioxide bubbles come out. Okay. We're just going to let that kind of react for a couple of minutes. Making sure it's mixed properly. Okay, now this part of your lab instructions is really confusing for a lot of students, and they don't write it in the best way. So that's why I'm going to just kind of show you what to do. So what we're going to do is we're going to use this pipette that was sealed, and we're going to transfer, and we want to use this one and not the other pipettes because this one is sterile, okay? And what we're going to do is we're going to transfer about 8 to 10 drops of this yeast solution into your hand, and you're just going to kind of squish it a little bit so that it kind of goes around your gloved hand. Your hand needs to be gloved, and then we'll use another one of our sterile swabs and get a sample of it, and then we're going to rub it into our yeast solution. So I'm just getting the sterile swab ready, and now I'm getting the pipette. I'm just going to make sure of something real quick. Okay. All right. So now, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so now we're just going to kind of squish it around to spread it out. And if you have to add a little bit more because you feel like it's just running off of your hand or something, that's fine. Okay. And yeah, so now it's like telling you to, you know, take your glove off and stuff like that. You don't need to do that yet. So I have some solution in my hand. I'm going to take out my sterile swab. I'm just going to go ahead and rub it around getting the yeast solution. And then what I'm going to do is I'm going to just hold it out like that because I don't want to get this into the petri dish, and I'm just going to pull it like that so that the yeast is inside the glove. And now I can just go ahead and inoculate the agar. So finding my yeast part, I'm just going to streak it. Remember, turn your cotton swab as you're doing it, so that way you're spreading it. Okay. So now, got that complete. I'm going to take the glove off. Okay. So now we're on, we've inoculated it. So it says now seal it with the parafilm and let it incubate in a warm location. I told you guys before that my parafilm didn't go well, so I'm actually going to wrap it with plastic wrap as much as I can. Forgot to get my plastic wrap before I did this. So here's right, so I'm just gonna make sure that it's secure and that it's. So I just wanted to show you the yeast after it's reacted. You can see it's formed it almost looks like a root beer float. This is what you want it to get to before you put it on that gloved hand. And this top part is the part that you want to go into your gloved hand. I know I didn't show that on the video, but I actually went back and took it and put it in my gloved hand and then re-inoculated the plate. So this is what you want it to do. Okay, so once I have wrapped my my Petri dish with my samples airtight to make sure that nothing gets in and nothing gets out. You're on step 17 now, or sorry, 16, and it says that you need to let it incubate in a warm location and observe the growth. You should see colonies in 2 to 5 days. Sometimes it can take 7 days for the yeast, so allow yourself at least 7 days for this to grow. Now, what you're gonna look for is like spots and kind of like moldy looking kind of growth. I've had students have really good luck whenever they put this in a dark, warm place. So like your closet with some clothes wrapped around it. Do not put it in direct sunlight. It will kill it. Okay, so no direct sunlight, a warm, dark place. And just every now and then, like every couple of days, just check on it. And once you start getting growth in all 3 areas, that's when you're gonna come back and do the next part. Hey everybody, I just wanted to show you what bacteria and yeast are growing. This is day 6. So you can see here on the local sample, there's some kind of red dots, a yellow dot, there's another little tiny red dot, and then there's a smear forming right here. So that's on my local sample. And then my skin sample, you can kind of see little yellow dots, there's a white dot, there's a little yellow right there. And then the yeast, I'm gonna back that out a little bit. It's kind of hard to focus in on, but these are more like greenish black dots. So this isn't quite enough to do the next part. I'm gonna let it grow for a couple of more days so that I can get good samples, because these are really small. And if I do it too soon, then the next part of the experiment won't work. So I'm just going to leave it there for probably maybe 2 more days. All right, everyone, so this is day 7, and I'm going to go ahead and do the second part of the lab for you. So you can see that my yeast sample has gotten pretty big. My local skin sample, or no, sorry, my local sample that I took from the light switch has got a couple of different growths. So here's one here, and then there's a couple of colored dots. And then I must have been really clean that day, or my forearm, because I didn't get a whole, like this part right here, that's where I scratched the agar. That's not growth. Instead, it's those dots that you see. So the first step that you're going to be doing now that you've had growth is you definitely want to make sure that you have gloves on when you do this, because you are handling bacteria and antibiotics. And if you have any kind of allergies to antibiotics, you definitely don't want to get that on your skin. I have quite a few allergies, unfortunately, so I'm going to definitely take precautions. Alright, so in your instructions, you are on the part that says to prepare the Mueller-Hinton agar plates. So you have the bottle of agar, Now this is different from the nutrient agar that you used. This is going to be a different one. And what we have to do is we have to microwave this bottle. I'd start with 10 seconds and then just kind of go every 5 until it's completely liquid and you can pour it. You want to definitely make sure that you have all of your materials ready to go, because this lab, or you want to take as little time as possible with this, because the longer you leave it exposed, the less likely your results are going to be working out well for you. So you want to have 3 Petri dishes. On the bottom, skin, local, yeast. You want to definitely have some isopropyl alcohol because you need that for sterilization. You need a beaker, you need your forceps and your inoculation loop. Don't take it out until you're ready to use it. You need a pipette. You need 3 standing test tubes, which you've also labeled skin, local, and yeast. Your candle, your antibiotic discs. They're really tiny and they come in 3 separate bags. Your forceps to put the antibiotic disc on the plate, and then your sterile cotton swabs. So I'm going to go ahead and microwave the agar, and I'll come right back to pour it. Okay, so it took about 45 seconds for the agar to heat up. I learned my lesson from the first time pouring the nutrient agar that I needed to make sure I got it all liquid, and it's really hot. So make sure you use the hot plate, or sorry, a hot pad. Do not heat it up 45 seconds at once. Like do it 10, 10, 10, and then 5, 5, 5. It goes really slow, but if not, if you don't do it that way, if you do it all at once, it's going to explode all over your microwave, and that's a problem, and that it's really hard to get out. So just go slow. So we already have our Petri dishes labeled, and we want the bigger side down. And so actually for this, actually what I want you to do is use the smaller side. So you have the deep side and then the small side. I want you to use the small side for this because they didn't give you a lot of agar. So, and I want to make sure you have enough for the 3 samples. So I'm going to go ahead and pour it. Wow, that's still really hot. Okay. Just going to kind of move this so that way you can see. So I'm just going to pour a little bit, and then I'm going to kind of shake it a little bit because you just want it to coat the bottom. Just want to get enough to coat the bottom. So you can kind of even spin it a little bit. Yep, see I got a chunk in there. That's what you don't want to have. Alright, and so I'm going to go ahead and cover it. Actually, alright, I don't want to cover it all the way because I want it to harden. Okay. So now I'm going to do my second one. I'm going to check and make sure that my agar is still liquid and I don't. So you might have to reheat it in the middle of this. It just depends. Yeah, mine's kind of, there we go. Okay. So you just need enough to coat the bottom. There we go. So you don't need, the whole thing. All right. And that's why I want you to use the small side, because I'm down to like my very last little bit. So if we were using the big side, you probably wouldn't get agar in all of these, and that would mess up your experiment. Oh goodness, see? Oh dear. Okay. So I'm actually going to have to put this, okay, well, it's coming apart, so that's great. All right, so I'm actually going to, yeah, see, I ran out. So I'm going to reheat it and come back. I'm actually going to put this in the microwave so that it'll kind of get the chunks loosened. So I'll be right back with that. Okay, so I poured the rest of my agar into the petri dish, and I ended up microwaving it to get a lot of the chunks out. They definitely do not give you enough agar because I used up the whole bottle. So, or I guess they give you just enough. So when you do this, what I really suggest is just pouring a little bit at a time and then swirling it to try and see if that little bit that you pour gets to where it coats the whole thing, and then just add a little bit more until you finally get the just the bare minimum coating, so that way you have enough for each one. So what you have to do now is we're going to let that sit. It's going to take about 30 to 60 minutes to harden, and sorry, reading the instructions. In your directions, it's on step 6 underneath preparing the agar plates. It says that you can use them, store them in the refrigerator. I wouldn't do that, honestly. I haven't had good luck when I did that. So I would wait for this to harden and then go ahead and proceed with the rest of your experiment. Like, don't wait. So yeah, so this will take about 30 to 60 minutes. And just kind of keep the big portions kind of off center, so that way they're not fully exposed to the air, and they'll harden without getting stuff in it. All right, so I'll come back when these are hardened and walk you through the next steps. All right, so my agar has hardened. So I'm now moving on to the part in your instructions that says prepare samples in suspension. I already have my 3 test tubes with caps labeled, and I just put tin, local, and yeast. And now it wants you to use your sterile pipette and your saline, your sterile saline solution. There's not a lot of that in there, unfortunately. So just be really careful. So the pipette actually goes up to 1 milliliter. It says that you need 2. So you're probably going to want to do it by 0.5, just a little bit at a time, because there's not enough of it in here to get 1 full milliliter each time. So I would just do it by 0.5s. So I'm going to start with my skin, and I'm going to flip this to where I can actually see it. Oh, actually it did go all the way up to the 1, so that's good. Alright, so there's 1. 2. And then you want to close it just as fast as you can, because we're trying to keep it sterile. Alright, and now moving on to the next one. This out of the way. Okay. All right, last one. There's 1. And 2. Okay, and so there's actually a little bit of sterile solution in there, so surprise, surprise, they, they gave you enough. And so I'm just gonna set this down. So it's not a whole lot, but it's enough to kind of fill the tip of the test tube. Okay, so now you're gonna go to your plate that is growing, has the bacteria on it. And so it says to remove the wrapping from it. So I already took my wrapping off. We're gonna go to the next phase, which is sterilizing your inoculation loop. And I know, like right now, there might be a little bit of supply problems with your isopropyl alcohol, because currently, while I'm filming this, the COVID-19 pandemic's going on. So you're just gonna have to keep looking for it, because you do need this alcohol to do the next part, to sterilize your loop. So it wants you just to pour a little bit into a beaker. You don't need too much. You just need enough to like do the bottom so that you can dip your loop in there. So see, it's not even to the 50 on the beaker. So all right, and then they want you to light the candle. Now I would keep your candle and your alcohol far away from each other because it's flammable. So here's a little tea candle that came in your lab kit. All right, so we got that going. So let me undo the loop, and then I'll come right back. Okay, so your inoculation loop already came in a plastic wrap. We're going to take that out. And we're going to dip the end of the loop, the circular part, into the isopropyl alcohol for 10 seconds. You might have to turn it so that way you can get it fully covered. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Now, just kind of tap it so that you get that part where it's not dripping. And then you just want to pass the inoculation loop through the flame several times to sterilize it. So you can see I'm just kind of holding it, and it actually it turns a different color. And then we're just going to blow the candle out. So don't touch this to anything because it's sterile now, and so we want to keep it that way. And now we're going to go to our bacteria plate, and you're going to transfer a colony from the skin sample and put it into this test tube. So we're going to start with the skin. And so basically what you do is you will put I'm going to try and come a little bit closer so that you can see what I'm doing. Let me make sure that you can see that. Nope, you can't. Okay, there we go. So I'm going to find a colony of bacteria, and I'm just going to kind of scrape a little bit to get the bacteria onto my inoculation loop, and see, I'm having kind of a hard time getting it out. So, oh no. Okay, so now it just went onto the floor. So we'll get this one. Okay. So I'm gonna undo my cap. And I'm going to not put this on the floor. I'm going to dip it into the solution, and then I'm gonna just kind of swirl, and see, you might have to straighten the loop out a little bit. I'm just gonna swirl it around in there and tap the inoculation loop against the side. So we're looking for it to kind of dissolve in the solution. I'm gonna get another piece of bacteria because that one that fell on the floor was quite a big chunk. So there we go. Okay, so that is done for my skin sample. And you're just going to repeat that same process for each one. And then you got to use these within 15 minutes. So definitely like keep going, don't stop. All right, so now we're going to go to the local sample, and same thing. Dip your, well, actually I'm gonna relight my candle. Okay. So dip your inoculation loop in there for 10 seconds. Tap it. Pass it through the flame a couple of times to sterilize it. The reason we want to do this is because we don't want to get bacteria that was in the skin sample mixed up with bacteria that we found in the local sample. So let it cool a little bit, because it does get pretty hot. And so now I'm going to take my local, and I have that big chunk right there, so I'm just gonna kind of swirl. Oh, yep, see, the agar is so fragile, so I'm just gonna kind of swirl it around, and then I'm gonna put it into the sterile solution and kind of mix it up a little bit. And then I'm actually interested in these red dots that formed, and that looks like I got some. There we go. Okay, so you definitely want to make sure all the bacteria goes into the saline solution and not on the sides of the test tube. Okay, so there's our local. And now we're going to do our yeast. One, two, three. Okay. Go ahead and sterilize it. Oh, I just blew on it. Shouldn't have done that. Okay, I'm gonna re-sterilize it. Alright, so now I'm gonna, those two big patches I have, I'm gonna kind of, interesting. It's not really coming apart very well. Oh goodness, okay. So yeah, this is kind of a delicate operation here. There we go. Got a good chunk in there. Also kind of makes me wonder if that's, maybe that's mold, which makes sense because yeast can grow that. Okay, so tapping it, kind of got, that part was really dry, so I'm just trying to break it up a little bit more so that it goes into the suspension well. I'm going to go ahead and blow out my candle. And I'm going to close this. Okay, so now this is the part that gets really confusing, because On step 9, it says once you've created the suspensions, pour approximately 5 milliliters of 10% bleach solution onto the surface of the nutrient agar plates. That is not the plates that you created, it's the bacteria plate. Okay, you want to pour the bleach on the bacteria plate to kill off any bacteria, because you don't know what bacteria you actually grew, and you could have actually grown a like staph resistant bacteria, and those are really bad. So pouring the bleach solution will kill off any bacteria that's on this, and then you just want to dispose of it, which I'm going to do later. I'm not going to do it right now, and I wouldn't suggest you do it right this second, because we have to use these suspensions within the next couple of minutes or else they will go bad. So pour that bleach later. So I'm going to set this aside because we don't need it anymore. And now we're on the part where we're going to inoculate the agar plates that you created. So we're going to go ahead and go to the skin one, and it wants you to remove the cap of the skin test tube, and then you're going to dip a sterile cotton swab into the solution. So I'm going to mix it up whenever I do it, like just twirl that and get it really wet and soaked through with that bacteria solution. And then I have my skin plate, and it says inoculate it by starting at one end of the plate and run the swab in a zigzag motion. So it's like this. So you take it and you just zigzag it all the way across. Then you turn it, zigzag, and I got that big lump in the middle. And if you feel like you're running out of solution, you can dip it back in there. So the important thing is that you cover the entire plate. And then you want to just kind of run it around the sides too. And so now we're done with that swab. And then we're going to take the cap and put it on there. And then you'll want to wrap it. Now mine has some condensation on it, so I'm going to have to kind of get that off. You definitely don't want to have condensation on it, so I'm just going to kind of wipe that away with my glove. And I'm going to undo the other ones because they kind of had condensation on it too. So now my skin is inoculated, my skin sample. So I'm going to set it aside, and then I'm going to close this, and I'm going to move on to my local sample. Take my next cotton swab and do the same exact thing. So swirl it. Okay, make sure you get bacteria. It'll look kind of cloudy onto the cotton swab. Okay, and then do the same thing, right? So we go zigzag pattern all the way across. Then we rotate it. I'm gonna get a little bit more because it's kind of running out. Okay, zigzag across. Rotate it one more time. Zigzag across. And then just kind of, oh, see my agar broke. Okay. Right. And that's okay. If your agar breaks, it's not too big of a deal because you still have enough of an area to do your antibiotic tests. Okay, and now we have just one more. Yeast. Now, unfortunately, my kit didn't come with enough sterile swabs, so I'm just going to have to use a regular Q-tip, which really stinks because this, oh my goodness, because this test tube is really long for a regular Q-tip. Okay. But I'm getting enough particles, so that's good. Okay, so same thing, zigzag pattern. Rotate. I'm actually not gonna re-dip it because I have enough. This Q-tip seemed to be more absorbent than the other ones. Okay. So now I've got all my plates inoculated, and we should be on the placing the antibiotic discs section. Okay, so the next section is going to be placing your antibiotic discs. You have 3 different antibiotics. You have ampicillin, kanamycin, and tetracycline. So first thing we have to do is we have to sterilize our forceps. So we're going to take the forceps and we're going to take the little piece that's holding it together off. And the way you're going to do that is the same way you sterilized your inoculation loop. You're going to hold the forceps into the isopropyl alcohol and then sterilize it with your candle. So I'm going to go ahead and undo my lids here for my samples. And what I'm going to do is, before I get started, I'm going to take I'm going to start with ampicillin and oh goodness, it's really hard to get that open with gloves. And I'm actually going to pour them out onto a bag, so that way I can access them easier. All right, so 10 seconds. Okay, knock off the excess isopropyl alcohol, and you'll see it flames up a little bit. Okay, and then I'm going to take my ampicillin disc and I'm going to just place it into I'm going to press it into the agar, not too hard. You'll see they're kind of slippery little things. There we go. You just give it a little tap so that it stays. So yeah, definitely put some pressure on it because you're going to be turning these upside down. Okay, so now I've got my ampicillin in there. Now you don't want to press it too hard. You just want to press it firmly enough so it stays. Okay. Actually, there we go. Okay, so now I'm going to go to my kanamycin. Put them on to the paper there so I can pick them up easier. sterilize my forceps. Okay, and I'm gonna make like a triangular pattern with my antibiotic discs. Because I don't want to put them too close together, because we want to see if the bacteria is resistant to it or if it's not. And the only way you can do that is by getting a measurement. All right, last one. This is my tetracycline. So it's going to be really important for you to do some research on what each one of these antibiotics does and what type of bacteria it treats and how it treats that bacteria, because that will help you answer your lab questions in your final report. Last one. Okay, and I just tapped it real gentle. Okay. Okay, so now we've gotten our antibiotic disc placed in each sample. So it should look kind of like this. And what's gonna hopefully happen is in about 5 to 6 days, there will be there'll be more bacterial growth, and it will either show a zone of inhibition or not. So the bacteria will either move away from the antibiotic, which means that it's working, or it'll be very close to the antibiotic, and that means it's resistant to that antibiotic. So that's what you're going to be looking for in each of your samples. So we're going to go ahead and close the sample, and you're going to incubate it upside down. So the label is going to be, the bigger part is going to be on the bottom, and the agar is going to be on top. And you'll want to wrap it with either your parafilm, or if you're like me and the parafilm didn't work, wrap it in your cling wrap, and put it back in that place that you were incubating your bacteria. So like mine was sitting under some clothes in a closet so that it's nice and warm. If I have had some students say that their antibiotic fell off whenever they stored it upside down, but that shouldn't happen if you press it in there really good. Now don't force it, because it'll break the agar and then it will come off. But if you just use real firm pressure, it shouldn't come off. So like I said, this is going to take about maybe even 6 to 7 days, because it took 7 days just for my yeast to grow enough to where I had enough of a sample. So after 7 days, we'll come back and we'll look at this, and that'll be it. In the meantime, while you are waiting for this to incubate and see your results, do like I said before, start researching what does tetracycline treat, how does it treat it, what does ampicillin treat, what does kanamycin treat, how does it work, and start trying to make accurate, or not accurate, but your best guess about what kind of bacteria lives on your skin, because and on your wherever you took your local sample, and do you think that bacteria would be treated by these different antibiotics, or do you think that it'll be resistant to them? And that'll kind of help you form your hypothesis part. Now this lab report that you are doing is a formal lab report, so it requires an abstract and an introduction. And so while you're waiting for these to incubate, you can complete those sections of your lab report and have that done ahead of time. So I will see you again in 7 days. Okay, so it is day 14, and the antibiotics have been given time to work on each sample. So the one that I'm just going to show you real quick, because I don't want to do it for you, is this local sample. You can see that there's no bacteria growth around the antibiotic discs. Now, the way that you want to look at this, it's hard to see on the camera, is put it underneath something dark, so that way you can measure the zones of inhibition. But if I bring it a little closer, you can start to see that dark area is where the bacteria has moved away from the antibiotic disc. And then the yeast sample looks pretty interesting. You can see that you can see the yeast. That's the dark part in the petri dish. So that's pretty much it. That's where you end. You measure the zones of inhibition with your ruler, and then that will be able to tell you how resistant the bacteria was to the antibiotic, or how effective the antibiotic was. All right.